Hello, grade 11s. Today we're going to be talking about molarity. What does molarity really mean? And it's a way that we measure concentration in chemistry classes. Now, since so many chemical reactions take place in solutions, it's really important for us to know the concentration of those solutions. We're going to have to know how much dissolved solute we have in a given amount of solvent. So the way that we do that in chemistry is by using a concept called molarity. We take a look at how many moles of solute are dissolved per liter of solution. And that simplifies to moles per liter, and of course chemists have shorthand for everything. We will often call that molar. Molar is a shorthand. It means moles of solute per liters of total solution, not liters of solvent. So let's talk a little bit more about what that means here in just a minute. There are lots of other ways that chemists can measure concentration. Sometimes you'll see them use grams per liters, parts per million and parts per billion are very common for very diluted solutions. They can also talk about the percentage, but percentage is measured in a lot of different ways. It could be weight, so the weight of the solute and the weight of the solvent. Or weight volume, how much the solute weighs compares to the liters of solvent, and volume in a liquid-liquid solution. No matter which of these ways that we measure concentration, however, there are always two measurements involved. How much solute, the part that gets dissolved, did we put in, and how much solvent, or total solution, do we end up making? Suppose I want to make a solution with a given molarity. Suppose I want to make 1 liter of a 1 molar solution of hydrogen chloride. Well, when I ask you this question, there are two numbers that I've given you there. I've given you 1 liter that I want to make, and I've given you 1 molar. So we're going to start with those numbers. 1 molar, of course, is shorthand, and what it really means is that I've got 1 mole of hydrogen chloride in every 1 liter of solution. When I say moles per liter, I'm implying 1 liter. So I want you to remember anytime you see the word molar, that shorthand hides 2 numbers and 2 units. 1 molar really means 1 mole over 1 liter. So I've got 1 mole over 1 liter here. It's my first given. But I have another given piece of information. I also want to make a liter. The 1 mole over 1 liter, both the top and bottom space are full here, because that's what 1 mole per 1 liter means. I could have asked to make 2 liters or 2.5 liters. So in this question, I was asked to make 1 liter, and so I'm going to put 1 liter beside. I have to put it beside because this first number, 1 molar, took up the entire first column. Now this sometimes bugs kids because there's a blank space here. Don't worry about that. That is really common in stoichiometry to have a blank space. These numbers are true because we were told they were true. They're given in the question. They don't need a top and a bottom component. At this point, liters is canceling and we're at moles. A little hint to solving molarity questions: if you can get to moles, you can usually figure out the answer to the question pretty easily. Now, we were asked how to make it, and I sure know that I can't measure moles in the lab. What I measure in the lab is grams. So to get rid of moles, I'm going to write the word moles on the bottom because things always cancel top to bottom. And I want grams, I'll put that on top. And moles to grams is molar mass. And if I calculate the molar mass of hydrogen chloride, I'll find out that it weighs 36.5 grams for every 1 mole. At this point, the word moles on the top cancels the word moles on the bottom, and we're at grams, so I would need 36.5 grams of hydrogen chloride. Now what do I do with it? I've got this little pile of salt hydrogen chloride. What would I actually do with that? Well, I would put it in a beaker, and then I would bring the volume up to a liter with water. Now, I want to make sure you don't ever write add a liter of water, because of course you're going to get a very incorrect answer. Let's look at why. Take a look at this pile of ammonium dichromate. in whatever situation they were making, we calculated we had to measure 90 grams of it. We were going to make it up to 250 mils of solution. So you'll see that in my Erlenmeyer flask, or my volumetric flask, sorry, I have put my 250 mils of my ammonium dichromate solution, and I've measured in a beaker carefully 250 mils of water. And now I'm going to pour that water into the beaker. I want to get it exactly to the 250 mils mark. When I do that, you'll notice I've got quite a bit of water left over. The salt itself took up some of the volume in the solution. Had I dumped this entire amount in, we would have an indeterminate amount of solution here, and the concentration would be incorrect. So I want you guys to always watch your language when you talk about how to make a solution. That when you add your water, you're bringing it up so the total combined volume of solute and solvent comes to the required amount. Now, there's really only two kinds of questions we can do in molarity. There are those questions that say calculate molarity. Sometimes they'll use the word calculate the concentration. In those types of questions, you're going to be given both a measure and a volume. Your measure is either going to be given to you in grams or possibly in moles. Either one of those is considered a measure, and start with it. Your volume will either be given to you in milliliters or in liters. So if you're asked to calculate molarity, start by putting your grams or your moles on the top of your factor label line and your milliliters or your liters on the bottom of the factor label line. Now, at that point, we'll start doing calculations to get things into the correct format. And I'll do an example with you. The other type of question is one that gives you molarity. If something gives you molarity, what they're giving you really, remember what molarity really means, they're giving you moles, and those moles are per liter. So when I say per liter, I mean per 1 liter. So if I was given a 2 molar solution, that's 2 moles per 1 liter. So if you're given molarity in a question, then it's important that you start with it in that question. But remember, change it to moles per liter because it's hiding 2 numbers and 2 units. We'll do an example of both of these for you. So let's take a look at this one. You have it in your book, and you can go along with me and copy out the solving so you can practice some of these on your own. What is the molarity of a solution that contains 30 grams of potassium hydroxide in 50 mils of water? You notice that this question gives me both a measure and a volume. Also, it's asking for molarity. It wants to know the concentration. So if you want to find molarity, and they do, then we're going to start by putting the measure over the volume. Now, I've changed my volume here right away to liters. How do I change milliliters to liters? Well, you divide by 1,000. There's 1,000 mils in a liter, so 50 divided by 1,000 is 0.05 liters. Also, a quick little trick you can do, I can see that there's a decimal point here on the 50. If I back my decimal point up 3 spaces, 1 for each of the zeros and the number 1,000, and then of course I have to fill in a 0, I get 0.05. So that's a quick way to change milliliters to liters in your head. So now I have 30 grams over 0.05 liters. I've started with my given piece of information, the 2 numbers that I had, and now what do I do? Well, a good way to figure that out is where is it you're trying to actually go? Well, what I'm trying to do is figure out moles per liter. And it's really helpful once you've written down your known information to go, where is it I'm trying to get with this information? I'm trying to get to moles over liter. Right now I have grams over liter, so I'm pretty close. I've already got liters on the bottom, and that's what I want. Problem is I've got grams on top, and what I want on top is moles. So to get rid of grams on top, I'm going to write grams on the bottom, and to get the moles on top, I'll write that there. I'm leaving a space for the numbers. Now, what is the truth that I can figure out between grams and moles? Well, that's molar mass. And we can figure this out as we learned in our stoichiometry unit by going to our periodic table and adding up the masses of 1 potassium, 1 hydroxide, and 1 hydrogen. That works out to 56 grams per mole. 1 mole of potassium hydroxide weighs 56 grams. Now look at what we've done. The units grams on top cancels the units grams on the bottom, and we are left with moles on top, which is what we want, and liters on the bottom, which is what we want. So now we're going to do a little math. Multiply across the top, divide across the bottom. So we'll go 30 divided by 0.05 divided by 56. And we see that we get to an answer of 10.7 moles per liter, or 10.7 molar, capital M, usually written in italics, means molar. You could write it either way. Let's try another one. In this question, we want to know how to make 25 mils of 2 molar HCl. Again, I have 2 given pieces of information. One of them, however, is molar, and when we're given molarity, we start with it, but we have to change this to moles per liter. So 2 molar really means 2 moles in every 1 liter. That's what 2 molar means. And it's important that we change this to moles per liter to remember that both the top and the bottom space are being used. What am I going to do with this piece of information, though? This top and the bottom has already been used. Well, at this point, all we can do is put it beside. There's no other place for it. Again, I'm changing mils to liters by dividing by 1,000 or backing my decimal point up 3 spots. Now, once again, I've got all of my given pieces of information written down, and it's important to know where the heck am I trying to go with this. I want to know how to make something. And right now, my liters will cancel. I'm at moles, and I know I can't measure moles in the lab. There's no magic mole measurer. So what I need to do is find grams. So that's important for us to know. We have liters canceling, so we're at moles. I want to get to grams, which means that I need to get rid of the word moles on the top and change it to grams. Now, I can't use this space. This was for my 2 given information, so we're going to add another column. I'm going to try to get rid of the word moles on the bottom, on top by putting moles on the bottom, and change it to grams by writing grams on top. Again, grams and moles has a truth that we know. It's molar mass. From our periodic table, if we add up hydrogen and a chlorine, we see that 1 mole of hydrogen chloride weighs 36.5 grams. At this point, these word moles cancels this word moles. Things don't have to be side by side to cancel, just top and bottom. We're now at grams, which is what we want. So at this point, we'll multiply across the top and divide across the bottom. And of course, multiplying and dividing by 1 doesn't change anything mathematically. So we'll go 2 times 0.025 times 36.5 gives us 1.82 grams. Now, what do I do with that? Well, I'd measure my 1.82 grams of HCl and put it into a container, and then I would add water until I brought the volume up to 25 mils with water. Please don't ever say add 25 mils of water. Like I showed you, we'd get a value that was much higher than what we'd expect. I want you guys to start by trying these 4 questions. You'll notice that I've given you the molar masses already for all of the salts involved. And each of these questions is either given molarity, start with it, or if you're asked for the molarity, put your measure over your volume. And you have a copy of these questions in your note package. You'll notice that I've also given you the answers to those questions. So we have them here as well that you can check to see if you've done them correctly. So this is going to be our quick starting point to see how you're doing with grams to moles and molarity questions. Once you've done these 4 questions, you can go and practice even more questions of the same in your textbook. On pages 42 to 44, they explain again the same steps on molarity, and there's a good set of questions, number 16 to 23, that you can practice as well. And hopefully when you're done, you're able to change molar to moles per liter, calculate the molarity if we're given a measure and a volume, calculate grams or moles if we're given molarity in liters, and explain using a sentence how to prepare a solution of a given molarity. So this in class usually takes us 2 or 3 days of practice to master. I'm going to get you guys to be working on these questions that we have, and by all means sending me emails or texts or chat messages through Teams to ask for any help that I can give you as we continue to practice molarity calculations.